In this section, you're going to learn how to write queries that summarize data. For example, you will learn how to write queries that report sales by clients or state, so we can see how much we have sold in each different state. These are the answers to some common questions that businesses ask. So the stuff that I'm going to show you in this section are extremely useful, especially if you work in a large organization with lots of data. Every single day, you'll have to write queries to summarize data. So let's get started. The first thing you need to understand is how to use aggregate functions in SQL. So a function, as I told you before, is a piece of code that we can reuse. MySQL comes with a bunch of built-in functions. Some of these functions are called aggregate functions because they take a series of values and aggregate them to produce a single value. For example, we have the max function for calculating the maximum in a series of values. We also have min, average, sum for calculating the total, as well as count. Now, with all these functions, as you can see, we'll have to use parentheses to call or execute them. Now, let me show you a few examples of these functions. So, in this demo, I'm going to use our SQL invoicing database. Let's select the maximum of invoice total column from the invoices table. There you go. So our highest invoice total is $189. Now look at the name of this column. It's set to the same expression we used here. So let's rename it to something more meaningful like highest. Now in the same query, we can also calculate the minimum. So min of invoice total as lowest. We can also add the average of invoice total as average. Let's execute the query. So here's our lowest invoice total, and the average of all our invoices is about $150. Now in this example, I'm applying these functions on a column that has numeric values, but you can also apply them on dates and strings. For example, we can change invoice total to payment date. Now, the value that we have here is the latest date when we received a payment. Okay, so let me revert this back to invoice total. We can also calculate the total of values in this column using the sum function. So sum of invoice total as total. And finally count to count the records. So invoice total one more time as number of invoices. Let's execute the query. So in this table, we have 17 invoices and our total sales is just over $2,500. Now, one thing you need to know about these aggregate functions is that they only operate on non-null values. So if you have a null value in this column, it's not going to be included in these functions. Let me show you where that matters. So as another example, I'm going to calculate the count of payment date. So let's rename it to count of payments. So as you know, this column accepts null values. So when we execute this query, we get 15 because not all of our invoices have been paid. So the count function returns the count of records with non-null payment dates. Okay. Now, if you want to get the total number of records in a table, irrespective of null values, you would have to use count of star. So as total records, let's execute it. There you go. So in this table, we have a total of 17 records. Now let me delete lines 6 and 7. We don't need them anymore. Another thing you need to understand here is that most of the time we use column names here, but we can also write an expression. For example, here we can write an expression like invoice total times 1.1. When MySQL tries to execute this query, first it will get the values in this column. It will multiply each value by 1.1, and then it will apply the sum function on those values. Okay. Also, if you have a filter here, these functions calculate the summary values for records that match your search criteria. For example, let's say where invoice date is greater than 2019, July 1st. So we only want to get the invoices for the second half of the year. Now, when we re-execute this query, we're going to see different values here. Let me show you. So we only have 7 records that match this criteria. And our total is also changed. So here we have the total sales for all the invoices issued in the second half of the year. And here's one last thing you need to know. By default, all these functions take duplicate values. If you want to exclude duplicates, you will have to use the distinct keyword. Let me show you an example. So instead of calculating the total number of records, let's calculate the records that have a client ID. So we get 7, but if you look at the data in this table, you will see that many of these clients are duplicated. Let's have a quick look here. So here's the invoices table. There you go. So we have client 5 duplicated in a few places. Same is true for client 3. So our count function is returning the count of records that have a client ID. It doesn't care if we have duplicates or not. If you want to count only the unique values, you will have to use the distinct keyword. So back to our query. Here in our count function, we use the distinct keyword. And now when we execute this query, instead of 7, we get 3 because we have 3 unique clients that have an invoice after this date. All right, here's a fantastic exercise for you to practice what you have learned so far. Write a query against the invoices table to generate this report. So here we have 4 columns: date range, total sales, total payments, and what we expect, which is the difference between these 2 columns. Now in this table, we have 3 records. First, we see all the amounts for the first half of 2019. Then we see all the amounts for the second half of 2019, followed by the total. So go ahead and spend 2 to 3 minutes on this exercise. When you're done, come back, continue watching. All right, first, let's calculate all the values for the first half of 2019. So we select a string literal or a label, first half of 2019, and we give it an alias as date range. Otherwise, the name of our column is going to be first half of 2019. That's not what we want, right? Next, we calculate the sum of invoice total and rename it to total sales. Then we calculate the total payments. So payment total as total payments. And finally, sum of invoice total minus payment total. And we call this what we expect. We're going to select all these values from the invoices table, where invoice date is between 2019 January 1st and 2019 June the 30th. So I'm going to put this on a new line so you can see clearly. There you go. This is our date range. This is our date range for the first half of the year, right? Let's execute this query. All right, this is what we get. Beautiful. Now we need to calculate the same values for the second half of the year. So to split things up, I'm going to copy this entire query. Then after our select statement, I'm going to write a union and then paste our select statement. Now we change this label to second half of 2019, as well as our search criteria. So we only want to select the invoices where invoice date is between July 1st and December 31st. Let's execute our query one more time. All right, beautiful. Finally, we need to calculate the total for all invoices in 2019. So one more time, we're going to use the union operator and paste our query. Then we're going to change the label to total. And finally, our search criteria is going to be from January 1st to December 21st. Let's execute the query one more time. And here's the end result. In the last lecture, you learned how to summarize data using aggregate functions. So here we have a simple query that calculates the total sales using the sum function. And here's the result. Our total sales is just over $2,500. But what if we want to see the total sales per client? That is when we need to group data by one or more columns. So here's how it works. Right after the from clause, we use the group by clause. And here we type out one or more columns for grouping data. For example, we can group data by client ID. And now when we execute this query, instead of one value, we see 4 values. These are the total sales for each client, but we don't see the client ID here, so let's add it to our select clause, client ID. And now, next to each client, we can see the total sales value. Now here, by default, data is sorted by the column specified in our group by clause, but we can change the sort order using an order by clause. So order by, let's say total sales in descending order. Now let's execute the query again. And here's the result. That is better. We can also apply a filter before grouping our data. Let's say we want to calculate the total sales for each client, but for the second half of the year. So here we use our where clause, where invoice date is greater than 2019 July 1st. Well, technically here we need greater than or equal to operator. So let's execute the query. Now we get a different result. So this is how we can group data using a single column. Now, before I show you how to group data by multiple columns, I want you to remember the order of these clauses. So just like always, first we have the select clause, followed by from. Now, optionally, we can have a where clause, followed by group by and order by. So the group by clause is always after the from and where clauses and before the order by clause. So if you put the order by first and execute the query, we're going to get a syntax error. Take a look. Because the group by clause is not valid at this position. So let's fix the issue. All right. Now let me show you how to group by multiple columns. So I'm going to join our invoices table with our clients table. Let's give it an alias, then join it with clients using what column? Client ID. Now let's have a quick look at our clients table. In this table, we have these columns like name, address, city, state, and phone. So let's say we want to group our data and see the total sales per state and city. So back to our query, we're going to change our group by clause and replace client ID with state and city. Now let's also change our select clause. So we're going to select the state and the city, and finally the sum of invoice total for each state and city combination. So to make things simple, I'm going to delete our where clause. That is better. Let's also remove the order by clause. We don't really need it at this point. Now look at what we get. Now that we're grouping by multiple columns, we see the total sales for each state and city combination. So when we use multiple columns in the group by clause, we get one record for each state and city combination. Now in this example, in our data set, we don't have multiple cities per state, but you're going to see an example of that as part of your exercise for this tutorial. All right, here's your second exercise for this section. It's a fantastic exercise. So we have a query that generates this report. We have 3 columns, date, payment method, and total payments. So we can see the total payments for each date and payment method combination. For example, on January 8th, we received a total amount of $32 using credit card and $10 using cash. So here we're grouping by multiple columns. Each group is a unique combination of these 2 values, date and payment method. Write this query against the payments table in this database. You will see my solution next. All right, here's the solution. Whenever I want to solve a complex problem, I start by dividing that problem into smaller and easier to solve problems. In this example, instead of grouping by multiple columns, let's start by grouping by date only. So we want to see the total payments for each date. That is easier. So let's select the date column as well as the sum of amount from the payments table. Now, let's give this an alias like total payments, and finally group our data by the date column. Let's execute the query. This is what we get. So we have solved almost half of the problem. Now, as you can see, our data is not sorted by the date column. So the next thing I want to do is to sort the data by the date column. So that is pretty easy. After our group by, we add order by date. Let's execute the query one more time. All right, here's the result. That is better. Now we're ready to add the second column, payment method. So if you look at the payments table, you can see that in this table, we only have payment method ID. So we need to join this table with the payment methods table to get the name for each payment method. That is pretty easy. We have done it before. So we're going to call our payments table P and then join it with the payment methods table. And we're going to call this PM. Now here we cannot use the using clause because our join columns are named differently. In the payments table, it's called payment method. In the payment methods table, it's called payment method ID. So here we'll have to use the on keyword on p dot payment method equals to pm dot payment method ID. Now that we have joined our tables, we go back to our select clause and pick pm dot name and rename it to payment method. And then we add payment method to our group by clause. So group by date and then payment method. Let's execute the query. All right. So here's the final result. For each date and payment method combination, we can see the total payments. Here's the example from the last tutorial where we calculate the total sales for each client. So we select the client ID column and the sum of invoice total from the invoices table and group our data by client ID. And here's the result. Beautiful. Now, what if we want to include only the clients that have a total sales of more than, let's say, $500? So we don't want to include client number 2. How can we do this? Well, we cannot use our where clause in this situation. So we cannot write where total sales is greater than 500 because at this point, we have not grouped our data. We group our data after. So on line 5, we don't know the total sales for each client. That is why we cannot use our where clause to solve this problem. If you execute this query, MySQL is going to yell at you saying unknown column total sales. So how can we solve this problem? That is where we use the having clause. We use the having clause to filter data after we group our rows. So here we can write a filter like total sales is greater than 500. Let's execute the query. Now client number 2 is excluded from the result. Beautiful. So with the where clause, we can filter data before our rows are grouped. And with the having clause, we can filter data after our rows are grouped. That is the difference. Now let me remove this where clause and make this example more interesting. For each client, we want to calculate the total sales as well as the number of invoices. So we can do a count of invoice total, or we could do a count of everything and label it as number of invoices. Let's execute this query one more time. There you go. So now for each client, we see the total sales as well as the number of invoices. Now let's say we want to filter this result and only return the records that have a total sales of $500 or more and more than 5 invoices. So we want to exclude the first 2 records because they don't have more than 5 invoices. So here in the having clause, we can write a compound search condition. So we want to get the records where total sales is more than 500 and number of invoices is greater than 5. Let's execute the query. And here's the end result. So to recap, we use the where clause to filter data before grouping our rows, and we use the having clause to filter data after we group our rows. And here, just like our where clause, we can type out 1 or more conditions. But the columns that we use here have to be part of our select clause. In other words, here, we cannot reference the payment date column because it is not included in our select clause, okay? In contrast, when writing a where clause, we can reference any columns whether we're selecting them or not. These are the 2 differences between where and having clauses. All right, here's a more challenging exercise for you. For this exercise, we're going to use our SQL Store database. So write a query to get the customers who are located in Virginia and have spent more than $100. It's a fantastic exercise and helps you get job ready. So spend 3 to 5 minutes on this exercise and then come back, continue watching. All right, once again, when solving a complex problem, we should always break that problem into smaller and easier to solve problems. So first, let's only get the customers who are located in Virginia. We write a query like this. Select everything from customers where state equals Virginia. And by the way, we should use the SQL Store database. So on the top, we have use SQL _store followed by a semicolon. Let's execute the query. There you go. So here are the 2 customers located in Virginia. Now, if you look at the columns returned here, nowhere in this result set we have sales information. We don't know how much each of these people have paid us. Where can we find that information? Well, in the order items table, we know how much we have sold in each order. So for each order, for each product, we know the quantity and the unit price. However, we don't have the customer information here. So we don't know who has bought these products. Those pieces of information are in the orders table. So in the orders table, we know who has placed what order. So what we need to do now is to join the customers table with the orders table so we can find the orders for each customer. And then we'll have to join the orders table with order items so we can calculate the total sales by each customer. So back to our query. We have selected everything from the customers table. Let's give it an alias and then join it with the orders table using the customer ID column. And then once again, let's join it with the order items table. We call it OI using the order ID table. Now let's execute this query and see what we get. First, we see our joined columns, which are order ID and customer ID. Then we have information about each customer, followed by information about each order. So we have order date, status, comments, ship date, and so on. And then we have information about each order item. So we have the product ID, quantity, and unit price. So now from this table, we can calculate the total amount each customer has spent. Back to our query, instead of selecting everything, let's select customer ID, as well as first name and last name. Now, to calculate the total amount each customer has spent, we need to use the sum aggregate function. And here we should write an expression. We go in the order items table and get the quantity column. Then we multiply it by order item dot unit price. So for each order item, we calculate the total cost, and then we pass all these values to the sum function. So this will return the total amount each customer has spent. Let's call that total sales. So here we have used an aggregate function. Now we need to group our data. So after the where clause, we type out group by. Here we should group our data by 3 columns: customer ID, first name, and last name. With this, we can see the total sales for each group, which is the combination of customer ID, first name, and last name. As a rule of thumb, whenever you have an aggregate function in a select statement and you're grouping your data, you should group by all the columns in the select clause. So I'm going to copy these 3 lines and then paste them here. Now we should remove the trailing comma. All right, let's execute the query and see what we get. So we see the total sales for each customer, right? We're almost done. The last part is to apply a filter here and only return the customers who have spent a minimum of $100. So we want to exclude the first customer here and return only the second customer. Back to our query. Earlier I told you that we use the where clause to filter data before grouping it, and we use the having clause to filter data after grouping our rows. So after group by, we add having total sales greater than 100. Let's execute the query one more time. Now we only see one record. That is customer with ID 2 who has spent a total of $157. So here's the end result. I hope you completed this exercise because a lot of problems you work on in the real world are very similar to what you saw in this video. Now, if you couldn't complete this exercise, don't worry, we're going to have more exercises like this later in the course. Once again, we're using the same example where we calculate the total sales for each client. Now in MySQL, we have a powerful operator for summarizing data called with rollup. So here in our group by clause, after we list our columns, we type out with rollup. Now when we execute this query, we get one extra row that summarizes our entire result set. So 2590 is the sum of total sales across all clients. Note that the client ID in this row is null because it doesn't make sense to add these values together. So the rollup operator only applies to columns that aggregate values. Now, what if we group by multiple columns? Let me show you. So once again, we're going to join our invoices table with the clients table using the client ID column. Now, instead of grouping by client ID, let's group by state and city, and also include these columns in our select clause. So state, city, and the sum of invoice total. Let's execute this query and see what we get. All right, here's what we get. First, we see the total sales for the city of San Francisco in California. And below that, we see the total sales for all cities in California. So the rollup operator calculates the summary for each group. Similarly, you can see the total sales for all cities in New York, as well as all cities in Oregon, and finally, all cities in all states. So when you group by multiple columns and use the rollup operator, you see the summary values for each group, as well as the entire result set. So the rollup operator is very useful and it has a lot of applications in the real world. However, it's only available in MySQL. It's not part of the standard SQL language. So you're not going to be able to execute this query in SQL Server or Oracle. But I'm pretty sure that those database engines have similar operators to summarize data. And here's your exercise for this tutorial. Write a query to produce this report. Here we have two columns, payment method and total. So we can see the total for each payment method, as well as the total amounts we have received. You need to write this query against the payments table. So go ahead and do this exercise. When you're done, come back, continue watching. All right, just like always, we start by simplifying our problem. So first, let's select everything from the payments table. So we get all these columns, but we're only interested in payment method and the total amount for each payment method. Now, our payment methods here are numeric values. So later we need to join this table with the payment methods table to get the actual name for each payment method. But let's not worry about that yet because we want to solve this problem step by step. So from this table, we want to pick the payment method column and the sum of amount. We're going to rename this to total. Now we need to group our data. So group by payment method. Let's execute the query. Here's what we get. Beautiful. We can add with rollup, and this adds the summary row at the end. Beautiful. Now finally, we need to join this table with the payment methods table to get the actual names. We give our table an alias and then join it with payment methods, PM. As I told you before, we cannot join these two tables using the using clause because the column names are not the same. So we use the on clause where p dot payment method equals pm dot payment method ID. Let's execute the query one more time. Beautiful. We still see the same result. Now we should replace this payment method ID with the actual name of the payment method. So pm dot name as payment method. Now, if we execute this query, we get an error in the output window because when we use the rollup operator, we cannot use a column alias in the group by clause. So here we need to type the actual name of the column. That is pm.name. That was a little detail that I probably forgot to tell you earlier. So sorry about that in case you couldn't solve this problem. That is totally fine. Let's execute the query one more time. All right, and here's the total result. So we see the total amount we have received for each payment method, as well as the total amount across all payment methods. And here's the final solution.